Hello, this is Rajdeep. Today I will explain you guys a very interesting concept in physics, mostly in astrophysics. The concept is time dilation. Okay, many students found it difficult to understand what is time dilation. So today I will explain you guys in very details and very easier concept way. Hope you guys have seen the beautiful English movie that is Interstellar. Whether you can remember that the person who was traveling by spacecraft and goes away from the Earth, then return to the Earth, then he found that his children is more than age than him. Okay, so what is the main reason behind this concept? That whether the person who is returning to Earth, they found that his children is more than elder than him. How this is possible? So this is the simple concept of physics. Okay, now I am explaining you what is time dilation. Okay, now let's see what is the time dilation. Okay, suppose here is a spacecraft that is in static position. Okay, let us assume you are standing here and you are observing this spacecraft that is in a static position. Okay, it's not moving, it's in static position. Let us assume it is sending a signal in a this direction and there is a mirror. Okay, mirror. So and the distance of the mirror from the spacecraft is, let us assume, that is h. Okay, so the signal will coming from the spacecraft and it will then reflect by the mirror and come back to the spacecraft. You are recording all the time duration. Let us assume that duration is total is t, the total time traveled by the signal from here to reflecting on the mirror then come back to the spacecraft. Its total time is t. So you can see the total distance traveled by the spacecraft is this one is h, and this total distance traveled by the signal is this one is h and this one is h. Total distance will be h plus h is equal to 2h. Okay, and this is the time. Okay, it's clear. Okay, so the velocity will be, we know distance by time, that will be 2h by t. Okay, this is okay, good. Now in the one interesting thing, the spacecraft is, we are assuming the spacecraft is in static position, but you know in the space nothing will be in static, everything will be in dynamic due to the gravity. So in this original case, this is a spacecraft that is in dynamic condition. So it is, let us assume this is moving this way. Okay, you are standing here and watching this spacecraft. Okay, so if the spacecraft is sending a signal here, okay, then it will reflect here. It will not never will get back to that its original position, because at that time the spacecraft will be not here, it will be move forwarded. It will be not here because it is in a dynamic mode, it will be move forwarded. Okay, in dynamic condition, if you sending a signal to a mirror, it will reflected by the mirror and it will never come back to this original position, because at that time spacecraft is moving towards the proper direction and it will be in dynamic. Due to its dynamic mode, it will be, you will not found this spacecraft at this place, you will never found this spacecraft at this place. It may be here or here or here. Okay, this is the basic concept. So originally the situation is, if you sending a signal from the spacecraft here, if there is a mirror and then you are receiving the signal here. Okay, so this distance is, let us assume h, but this is a sending path and is a receiving path. This distance is h. Okay, but the signal travel, the total path, let us assume this path is L and this path also is L. Okay, the signal traveled, the total path is L plus L is 2L, and time for this phenomenon, the time taken for this phenomenon, let us assume time is t prime. Okay, in static mode we assume the time is t, in dynamic mode we assume the time is t prime for this phenomenon. Now you can see in basic way that is L plus L 2L is much more greater than H. This is a very easiest concept. You can see it by the picture. H is this distance. Okay, but L plus L, total distance, L plus L much more greater than H. Okay, so now velocity will be total distance by time. Okay. Basic, so in static we found that velocity will be 2h by t. In dynamic, that is I am considering is v prime, velocity will be 2l by t prime. Okay, from here equation number 1, equation number 2. From equation number 1 we found the time for static event is 2h by v. From equation number 2, time for dynamic event, that is 2l by t prime. Sorry, t prime is 2l by v prime. Okay, now in the space, whether there is a spacecraft or a spaceship or anything, space object, any space object which is moving, let us assume that velocity is nearly equal to c, that is the velocity of light. Okay, nearly equal to c, the velocity of light. C means velocity of light. Okay, that is the highest velocity. Okay, any object can attain is the highest velocity, that is the velocity of light. So for this phenomenon we can assume that for any spacecraft which is in static position, the time will be 2h by c, or for in dynamic position time will be 2h by c. Okay, the most interesting part is, sorry, 2l by c. Most interesting part is time t is much more lesser than time t prime. Okay, how can you say this? T is 2h by c, t prime is 2l by c. Okay, but we know that L is much more, 2L is much more greater than 2h. Okay, 2L is much more greater than L, well, you can say L is much more greater than h. This distance is much more greater than this distance. This distance is much more greater than this distance. So yeah, so here we found that t is much more lesser than t prime, because here is t is 2h by c and t prime is 2l by c. L is greater than h, so t prime is larger. Okay, the practical incident is that, okay, t prime is larger, t prime is larger than t. Practical incident that we are in earth and here space is moving. Here the spaceship is rotating this way. Okay, and maybe it is following the another orbit, whatever, or it is following the another path. So this, in this case, the relativity is called relativity case. In this case, we will calculate the time as t prime, because here the spaceship is also moving and Earth is also orbiting to its own axis. Okay, this is the t prime. Okay, and t is the case the spaceship is here and the astronaut is sitting in this spaceship. For that case, that will be the t. Okay, for that case, that will be the t. Means, as per the interstellar movies, the person, the astronaut who was moving from the Earth to other planet, like just like Mars, for him there will be calculation of t, because for him he is static by by his own spaceship. As per as respect of reference, he is static here. Okay, but in other manner, the person, just like his daughter or son, as per them, he is moving away from the earth, and for there is an relative velocity for him. So in that case, there will be t prime. Okay, so that's why when he returned to the earth, he found that his daughter or son age is more than his own age, because maybe his daughter or son age will be 60, his age will be 30 when he leaves from the earth. This is the basic preliminary basic concept of time dilation, basic concept, and there's is much more physics here, there is much more calculation here, much more velocity equations here. That is other part. This is the basic concept of time dilation. Time dilation means the delay of time. The delay of time. Delay of time, because when he left the earth, his age was 30, but when he after 5 years or 6 years, when he returned to the earth, his age must be in plus 5 35, but he found that his son or daughter is now 60 when he returned to the earth, because as per his son or daughter, they will calculating time just like t prime, but real time is t for as per him. So t prime is much more greater than t. This is called basic time dilation. Okay, this is the basic time dilation concept. Thank you.